Imagine a massive cargo ship crossing the Pacific, and it's carrying like $50 million worth of electronics.
Right, a huge payload.
Yeah, massive. And out of nowhere, it hits a severe storm and gets delayed by 3 days. Now, if this happened in the 1990s, that delay would mean just absolute chaos.
Oh, totally. Phones ringing off the hook, missing inventory, completely panicked store managers.
Exactly. But today, an invisible digital brain instantly detects that delay. I mean, without a single human lifting a finger, it reroutes a fleet of delivery trucks in Europe.
Wow.
Yeah, and it slows down an assembly line in Mexico so they don't run out of parts. It even automatically adjusts a retailer's marketing spend in Tokyo just because the product won't be on the shelves in time.
And the crazy thing is, it is entirely invisible to the consumer. I mean, it's the absolute definition of mission critical, but we just expect to click buy and have a physical product miraculously appear on our doorstep the next morning.
Like magic.
Right? Like magic. We are completely unaware of the massive real-time computational acrobatics happening behind the scenes to make that possible.
Exactly. And, well, that is our mission for today's deep dive. We are going to decode this complex world of enterprise technology.
It's a huge topic.
It really is. We are looking at, how massive organizations actually figure out what tech they need, the central nervous systems they use to run their global supply chains, and crucially, how they manage to upgrade these massive systems without accidentally shutting down their entire business in the process.
Which is much, much harder than it sounds, by the way.
Oh, I bet. So for you listening, if you've ever wondered how global commerce actually thinks, you are in the right place. Okay, let's unpack this. Before a company even writes a check for a multi-million-dollar software system, they have to figure out what they actually need.
Right.
Because you can't just go to a store and buy business software off the shelf.
No. Definitely not. You have to perform what's called a technology gap analysis.
Gap analysis, okay.
Well, yeah, because the absolute worst thing a company can do is just buy software because it is new or shiny or, because their competitors have it.
Oh, the fear of missing out.
Exactly. Corporate FOMO. A technology gap analysis is a very rigorous, structured process. You start by mapping out the exact current state of the business. Like, where are you right now?
Okay.
Then you define the desired future state. Where do you desperately need to be in 5 years to survive? The space between those 2 points, well, that is your gap.
That makes sense. And companies don't just, guess at this, right? I mean, they use specific analytical tools.
They do, yeah.
One of them is benchmarking. So if you look at your industry and see that your biggest competitor can process a custom order in 2 hours, but it takes your company 2 days.
Yeah, that's a problem.
Right. You immediately know you have a critical gap in your order fulfillment process. Or they draw out these incredibly detailed flowcharts of exactly how a process works today.
And those flowcharts are incredibly revealing. I mean, when you force a department to map out every single physical and digital step of how they, say, onboard a new vendor, you really start to see the absurdity of it.
Like what? What do you usually see?
Well, you see that an employee is downloading a spreadsheet, emailing it to another person, who then manually types those exact same numbers into a totally different system.
Oh, wow. Yeah, that's painful.
It's a huge bottleneck. But here is the real aha moment of this whole process. A technology gap analysis frequently reveals that you don't actually need new software at all.
Wait, really? The conclusion of a massive tech analysis is often just, don't buy tech.
Quite often, yeah. It frequently uncovers untapped uses of the technology they already own.
Oh, I see.
The software might have a feature that automates that exact spreadsheet problem, but no one was ever trained on how to use it.
I love that point. It is like buying a water-cooled, top-of-the-line gaming PC loaded with a massive graphics card, and you only use it to check your email.
Yes,
yeah,
exactly.
It's just a massive waste of money if your desired future state is just reading plain text. But let me push back on this a little bit.
Sure.
If a company maps all this out and finds these massive inefficiencies, is a tech gap really just a people problem in disguise?
That is a very perceptive question. And honestly, you are hitting on a fundamental truth in operations management.
Yeah.
Yes, very often, the gap is entirely human.
Right.
When you map the current state, you often reveal critical gaps in human resources, like a lack of training, a resistance to change, and even gaps in the capabilities of your supply chain partners.
So it's not just internal.
No, it's external too.
Yeah.
And if you ignore the human element, the technology will fail. Every time.
So you can't just, install a massive software update overnight and expect the humans to magically upgrade their brains too.
Precisely. Any technology investment has to be supported by parallel investments in workforce development. If the users do not understand the new process or they just lack the basic skills to use the new tools, your desired future state will remain a total fantasy.
Just a pipe dream.
Right. Technology amplifies a process. If you digitize a broken, inefficient process, you just get a really fast broken process.
Okay, that is a great way to put it. So let's say a company has done the hard work, they've mapped the gap, they realize they have these isolated departments wasting time, they're ready to invest in their people,
Yeah.
and they realize they need a way to build a bridge between all these isolated islands. How do they actually do that? It brings us to the big one, right? ERP.
Enterprise resources planning.
Yeah.
Yes. It is the core engine of any modern business.
Okay, break that down for us.
At its most basic architectural level, an ERP system is a single, massive, shared master database. It connects all the disparate modules of a company: customer relationship management, human resources, finance, logistics, manufacturing.
All of them.
All of them. They all feed into and draw from one single source of truth.
Wait, I'm stuck on this because if finance and logistics are entirely different disciplines, I mean, they care about totally different things.
Right, they do.
How does one single software system force them to speak the same language without breaking their individual specialized processes?
By standardizing the data. See, before ERP, finance had their database, logistics had theirs, sales had theirs.
So it's total silos.
Complete silos. If an order changed, someone had to manually update 3 different systems, and they inevitably made a mistake. The ERP forces everyone to use the exact same data fields.
Oh, I see.
Yeah, so when a salesperson enters an order, the system instantly, automatically updates the inventory count, triggers a manufacturing requirement on the factory floor, and flags finance to prepare a bill. It is completely seamless.
Here's where it gets really interesting, though, because this massive all-knowing system didn't just appear out of nowhere in the digital age.
No, it took decades.
Right. If you look back at the history, this tech didn't start out running corporate finance or human resources. It started in the 1970s as something called MRP, Materials Requirements Planning.
Yes, early MRP.
It was literally just a tool with the processor to figure out what raw materials were needed on a factory floor.
Exactly. It was essentially an automated calculator for the bill of material.
Okay, and for anyone listening who is unfamiliar, a bill of materials is basically just the ultimate recipe card for building a product, right?
That's a perfect analogy.
Like if you were building a tractor, the bill of materials lists the exact number of screws, tires, and steel panels you need. Early MRP just looked at that recipe and told you what to order.
Yep, very simple. But then it evolved into MRP closed loop.
Closed loop, meaning it finally had feedback, right?
That's right. Because the original MRP would tell you to order 4 tires, but it wouldn't check if the machine that attaches the tires was broken.
Oh, that's a pretty big flaw.
Yeah, it was blind to reality. So MRP closed loop added that feedback. The system could finally tell you if the manufacturing plan was actually feasible based on your current factory capacity.
And then it evolved again into MRP2, which stood for Manufacturing Resources Planning, and this was a massive leap from what I understand.
Huge leap.
It added best practice processes, a common database, and most importantly, sales and operations planning, or S&OP. It finally connected the sales team to the factory floor.
What's fascinating here is how revolutionary that connection was. Because without that connection, you have a classic business disaster waiting to happen.
Like sales writing checks the factory can't cash.
Exactly.
Huh.
The sales team promises a customer a massive order of tractors by Tuesday just to hit their commission goals, but the factory physically cannot build them until Thursday.
Right.
MRP2 stopped that by forcing sales and manufacturing to plan together based on reality.
And then finally, it mutates into ERP, adding total cross-functional software and process integration.
The final form.
Yeah. So the system, originally designed just to count steel widgets on a factory floor, evolved to process payroll and HR and manage the corporate general ledger and finance.
It's amazing when you think about it.
It really is. And if you want to know why you, the listener, no longer have to fill out 5 different paper forms in triplicate just to request a week of vacation or file an expense report, you can thank the evolution of ERP for destroying those departmental silos.
It truly is the central memory and the nervous system of the company. However, ERP has a limitation.
Okay, what is it?
It is fantastic for the overall business rules, but when you get down to the sheer chaotic physical reality of a global supply chain, The delayed trucks, the broken factory machines, the rerouted raw materials.
The messy stuff.
Right, the messy stuff. ERP is actually not fast or specialized enough to handle it in real time.
Ah, I see. So ERP is the brain, but it needs something else to actually move the limbs.
Exactly.
That is where APS comes in, advanced planning and scheduling.
Yes. If ERP is the central brain managing the long-term business rules, APS is the specialized motor cortex managing the rapid physical reflexes of the company.
To really understand why APS is so vital, I think we have to look at the older method companies use, which is called RCCP, or Rough Cut Capacity Planning.
Oh boy, yes.
And rough cut sounds exactly like what it is.
It is incredibly rough and deeply flawed for modern commerce. RCCP basically just uses historical load data to plan work center capacity.
So it's looking backwards.
Yeah, and very narrowly. It looks at one machine or one factory floor and asks a very simple question. Do we have the machine hours and human hours to build this order this month?
But what does it ignore? Because it sounds like there's a catch.
It completely ignores logistics capacity.
Oh.
Yeah. RCCP assumes that if you have the machine time, you can magically teleport the raw materials to the machine and magically teleport the finished product to the customer. It basically assumes infinite warehouse space and infinite trucks.
Which is a terrible assumption. I mean, if you build 1,000 tractors, but there are no trains available to move them, your factory floor turns into a parking lot and production halts anyway.
It's a disastrous assumption. APS, on the other hand, solves this by integrating production capacity analysis and logistics capacity analysis.
It does both.
Both. And it doesn't just do it for one factory, it does it across multiple global sites simultaneously. It calculates based on available materials, available labor, and plant capacity all at once, in real time.
So what does this all mean in practice? Let's upgrade our metaphors here. We often hear APS compared to a grandmaster chess player, but it's really more like an automated global air traffic controller.
That's a great way to look at it.
Like if a machine breaks down in your factory in Mexico, APS instantly sees that you can't hit your production target. It automatically checks the ERP to see where else you have capacity, finds an open machine in your Canadian factory.
Yeah.
It checks the logistics network to ensure there are trucks available to move the raw materials there, and reroutes the entire workflow before a human manager even realizes the Mexican machine is broken.
That real-time adjustment is the true power of APS. It takes the massive transaction and operational data from the ERP, uses highly complex optimization inputs, and feeds optimized schedules right down to the manufacturing execution level.
Wow.
Yeah, it handles short, intermediate, and long-term time horizons. It actively analyzes supply and demand to prevent bottlenecks before they ever occur. It strictly synchronizes the velocity of the physical process flow to match what the customer is actually buying.
Okay, so we've mapped the gap. We've bought the massive ERP brain. We've got the APS air traffic controller managing the physical logistics. Now comes the truly terrifying part.
The cutover.
Yes. How do you actually install these massive, company-wide, deeply entangled software systems into a living, breathing corporation without bringing everything to a grinding halt?
It is arguably the most dangerous phase of a company's life cycle. You need a highly detailed technology cutover plan. I mean, it is not like performing a heart transplant on a runner. It is like trying to change the tires on a bullet train while it is moving at 200 miles an hour. Yeah. You have to somehow lift the train, swap the wheels, and set it down without the passengers even spilling their coffee.
So there are 3 specific ways to execute this cutover. The first is a go live, which is just a direct hard switch.
Right.
You turn the old system off on Friday and turn the new one on Monday. The second is a cutover while maintaining the old system, basically running them both simultaneously.
Parallel running.
Exactly. And the third is a rolling cutover, where you implement it site by site or module by module.
Each strategy has its place, but the groundwork is universal. Long before you flip the switch, you have to establish clear maintenance policies, develop the necessary skills in your workforce through massive training programs, and ensure you have all the hardware and parts inventory ready to go.
All right, well, I have to play the skeptic here. Looking at those 3 options, why wouldn't a company always, like 100% of the time, choose to maintain the old system alongside the new one?
It seems like common sense, right?
Yeah. Why ever take the insane risk of a hard go live? Running both seems like the only safe bet. If the new system crashes, you just go back to the old one.
It sounds incredibly safe on paper, but running parallel systems introduces a completely different, deeply insidious set of hidden dangers.
Like what?
Well, think about the data entry. If you are running 2 ERP systems, your employees literally have to enter every single transaction twice.
Oh, wow. Yeah, that sounds incredibly tedious.
It duplicates work, which destroys productivity. But worse, humans make mistakes. Imagine an employee typing a complex 14-digit part number into two different screens at 4:30 p.m. on a Friday.
They're definitely going to mistype one.
Exactly. Very quickly, the data in the old system stops matching the data in the new system. Now you have fractured data.
That's a nightmare.
A total nightmare. When finance goes to close the books at the end of the month, and one system says you made $1 million and the other says you made 900,000, which system do they trust? Plus, you are paying double in software licensing and server fees.
So you are essentially paying double the money to completely confuse your own company.
Exactly. Now, a hard go live does carry immense immediate operational risk. We have seen monumental failures here.
Right.
Back in 1999, Hershey tried to execute a hard go live. Go live with a massive new ERP and supply chain system right before Halloween.
Oh no, Halloween for a candy company?
It was a disaster. They couldn't get the candy to the stores. They lost an estimated $100 million in sales, and their stock tanked.
See, that is exactly why I'd be terrified of a hard switch.
It is terrifying, which is why managing risks and ensuring absolute business continuity are critical to whichever cutover plan you choose. A hard switch forces the organization to adapt immediately. There's no safety net to fall back into old habits.
Right.
But because of the risk, a rolling cutover is often a very popular middle ground for large multinational companies. You transition the European factories first, you work out the inevitable bugs in the system, and then a few months later, you transition North America.
That makes a lot of sense.
But whatever you choose, you absolutely have to secure 24/7 vendor support and have aggressive business continuity plans ready for when things break, because they will break.
Okay, that makes total sense. So let's assume the company survives the cutover. The core ERP and APS systems are securely in place. Now we look at the future.
They're fun stuff.
Right. We look at the external technologies that plug into this ecosystem, and there is a really wild juxtaposition here between the reliable, established workhorses of the industry and the bleeding edge of the future.
The foundational established tech we absolutely have to mention is EDI, electronic data interchange.
Right, which has been around for decades. And for those who don't know, EDI is the standardized paperless exchange of business documents.
Yes.
We're talking purchase orders, shipment authorizations, advanced shipping notices, invoices. It is basically computers talking directly to other computers in a standardized language.
It is not glamorous in the slightest, but it is the invisible plumbing that keeps global trade from drowning in paper. Without EDI, the global supply chain would completely halt. But then you pair that invisible plumbing with decision support systems.
And what are those?
These are AI-enabled systems specifically designed to aid human managers. They draw data from multiple sources, filter out the noise down to a manageable level, load it into a mathematical model, and actively suggest actions. Like you should order more copper now because prices are trending up.
And the list of emerging tech that plugs into this infrastructure is practically a buzzword bingo of the modern tech landscape.
Oh, absolutely.
We are talking about cloud computing, machine learning, data analytics. We have blockchain for traceability. We have the Internet of Things, or IoT.
Let's define some of those because they get thrown around a lot. IoT in a supply chain usually refers to sensors and telematics.
Okay.
Telematics are the GPS and engine sensors on delivery trucks that track location and fuel efficiency in real time. IoT also includes, like, temperature sensors on shipping containers. We also see the rise of 3D printing for localized manufacturing, robotic process automation, or RPA.
Which is essentially a software bot, right? It takes over the mind-numbing, repetitive clicking and copying and pasting that humans hate doing.
Exactly. It automates the digital manual labor. And finally, things like wearables and augmented reality headsets for workers on the warehouse floor, guiding them exactly to where a product is stored.
It is a dizzying array of technology.
It really is. But if we connect this to the bigger picture, none of that emerging cutting-edge tech matters one bit if your core systems are a mess.
Wait, what do you mean?
Take machine learning and AI. Every company wants AI right now. But an AI model is completely useless without vast, vast amounts of clean, structured data.
Right, garbage in, garbage out.
Exactly. Where does the AI get that data? It gets it from the ERP. And where does the ERP get its baseline transactional data? From established, unglamorous tech like EDI. You cannot implement AI if you haven't first successfully executed your technology gap analysis and built a rock-solid ERP foundation.
So it all stacks together.
It has to. Or look at blockchain. Blockchain is incredible for tracking a product's provenance. Say, proving that a diamond was ethically mined or a pharmaceutical drug was kept at the right temperature.
Yeah.
But if your internal master data governance in your ERP is flawed, or if your employees are just typing in the wrong numbers, you are just securely, immutably recording bad data to the blockchain.
Wow. So the boring stuff is actually the strict prerequisite for the cool stuff. You can't have the augmented reality warehouse worker seeing digital arrows guiding them to a shelf if the central ERP system has corrupted data and doesn't actually know where the inventory is.
Exactly. The digital nervous system relies entirely on the integrity of its most basic synapses. If a truck hits a pothole and an IoT sensor detects a temperature spike in the refrigerated cargo, that sensor has to talk to the EDI, which feeds into the ERP, which alerts the APS to instantly reroute a backup truck.
A chain reaction.
Right. And if any link in that chain is broken, the ice cream melts.
Okay, let's recap this massive journey we've been on. For anyone looking to understand how enterprise tech actually operates under the hood, it all starts with identifying the gap between where you are and where you desperately need to be.
Step 1.
And realizing that fixing that gap often means buying less software and investing heavily in your humans. Then you build the central brain with an ERP system, a technology that evolved from simply counting screws on a factory floor to completely destroying the siloed walls between finance, sales, and manufacturing.
It's an incredible evolution.
It is. Then you give that central brain the muscle and rapid reflexes it needs with an APS system, turning it into a real-time global air traffic controller to handle the chaotic logistics of the physical world.
Yeah.
You somehow survived the terrifying cutover by managing your risk, avoiding fractured data, and maybe not doing it all right before Halloween.
Definitely avoid Halloween.
And finally, you build on that rock-solid foundation with AI, IoT sensors, and whatever comes next.
Which brings us to the ultimate ongoing challenge of operations management. This raises an important question.
Okay, let's hear it.
We said at the very beginning that a technology gap analysis moves a company from its current state to a desired future state. But technology never stops evolving. The finish line does not exist.
That's true.
So what happens to a business when the cutting-edge future state they spent tens of millions of dollars and 3 grueling years implementing yesterday suddenly becomes the outdated, rigid current state they're desperately trying to escape tomorrow?
Oh, wow.
How do you build a digital nervous system that actually embraces continuous change rather than structurally resisting it?
Oh, I love that. The finish line is always moving, something for you to chew on next time you click buy, and expect the world to seamlessly, magically deliver a package to your door by morning. Thank you so much for joining us on this deep dive. Keep questioning, keep exploring, and we will catch you next time.